My name is Vishali Balu and my metric number is B0920100453. Today I will explain about the system involved in the structure and the idealized development for the system. There are 14 joints, 16 trusses and 12 members in this structure. This diagram shows the common roof truss. This diagram shows the idealized model based on our free body diagram. There are three major joints in this diagram where pin joint. Pin joint truss is a structure made up of separate components by connecting them together at pin joint or knots, usually to form a series of triangles. The second joint is in order to simulate a perfect beam behavior where there are no axial stress in the truss cord as the vertical load is applied. So if the temperature of the beam is raised, there is no room for thermal expansion for the beam in the horizontal direction. Last but not least, fixed collar support joint. Fixed support can resist vertical and horizontal forces as well as the moment because they can restrain both rotation and translation that known as rigid support. So that makes the structure only need one fixed support in order to be stable.
Hello, my name is Safura. I will explain about free body diagram of the structure. This is our structure, roof truss. Here is our assumption of the structure. We assume that 500 Newton is the weight of the roof and we give the length of each member and label the point of joint. And for the free body diagram, we took the cut-off section here. So at point A, AY is normal force because it is not fixed, so the force at point A is only AY. Then there is force IJ and there is also force BC. That's all from me. Thank you.
I am Yap Yong Nguyen from BMD S1/1. Today me and Yong Shou Jae will present about the equation of equilibrium for our assignment. First, this is the free body diagram for our assignment. First, we take moment at point G. We know that summation of moment equal to 0. By in all the moment inside, we get our AY is equal to 1750 Newton. Next, we apply the method of section to our free body diagram. We cut it into two sections. One is A and one more is B. So this is for the section of A. So when we take moment at point D, we know same thing, summation of moment equal to 0. We putting all the moment inside the equation. We will get FKL is equal to 2737.64 Newton and the sine 9.46. The 9.46 is the angle for the FKL. We found the angle by using the trigonometry ratio. Next, this is the section B. So at point K, we using the summation of Fx equal to 0. We put in all our Fx. We will find our Fjk is equal to 2737.64 Newton. Then we use summation Fy equal to 0. We put in all our Fy. We found that our FKD is equal to 399.91 Newton. Next, we use the method of section, cut it vertical to separate it because we know that left hand side is equal to right hand side. So we take half of it only. So first, we apply the equation of summation of Fy equal to 0. We put in all our Fy value into the equation. And the sine 33.69 is the angle for FJD. We using the trigonometry ratio to get the angle. We can get our FJD is equal to negative 360.48 Newton. We can know the force of FJD is compressed due to the negative value. So our FJD is 360.4x compressed. Next, we using the summation of Fx equal to 0. We can find our FCD is equal to 2400.30 Newton.
After using the method of section, let's move on to the next. Since we get the fjk, fjd, so we are able to substitute into the equation as it and join j to get the value of Fij. For the y-axis, let all the force into component y so that we are able to create an equation of equilibrium EOE. Finally, we get the value of Fjc. Next, to the joint C. Do the same thing that like just now, solve all the force into the component S and Y to get the EOE and get the value of unknown. Besides that, our group facing a problem at this part before because we simply assume the joint C has zero force member. Even joint C have no external force and separation but equal force members, so then it should not be a zero force member. Then there are the same things that like previous to calculate the force in the members by part by part. By using all the force to solve it into S and Y components to get the value of unknown. Last and foremost, the combination for all the force are already listed out, and the last is the properties of the member. Since all since the force to the joint are the member opposite when the force yellow acting towards the joint, so it creates an opposite force to the member, so the member shows a compress. Next to the joint right hand side, there is the force outward to the joint, so create an opposite force to the member, so what we call is the tension.